Hello, you're welcome. We are going to continue our discussion or our next topic that is based on kinematics. And the first on the list to discuss in this bit of video will be describing motion. These are going to be our learning aims. We are going to define average speed, velocity, and acceleration and describe the motion of an object in terms of these words. Now, what does it mean to move? If an object moves, what does it mean? It simply means the body has changed position. In your screen, you can see a point labeled O, and there are two new points, A and B. A particle or two particles have moved from O, one stopped at A and another stopped at B. We say the particle at A has moved because it has changed from position O to position A. And likewise, the particle at B, it has changed from position O to position B. So we say these two particles have moved. They've simply changed position. Now, this position changing is not like magic whereby the object just disappears from O and reappears in A or B. No. It may have to travel some distance. And it is not enough to say it has moved. Many of us will want to find out how far has it moved? How far has the particle moved? We can put a value on how far by using a calibrated instrument. The simple one you can see on the screen will be a meter rule, or just the simple ruler that we use in our classrooms. You just place it close by the two positions and you can tell how far the particles have moved. Again, how far, being the length or being the distance from the initial point to the final point, is still not enough. Many a times you may also want to find out how long does it take to move from the initial point to the final position. And that's why we will need a clock, another calibrated instrument, a clock or stopwatch to measure the time it takes particle A to move from 0 to point A and particle B to move from point O to point B. So these two quantities, how far, how long, or the distance and the time, we can put them together to arrive at another quantity called the speed. So if we know the speed of a particle, we can answer how far within what time. So these two quantities, which is the how far, telling us the length, distance, and then the time it takes to move from one position to the other, can be put together to obtain another quantity called the speed or the velocity of the objects. Next week, we are going to talk about scalar and vector quantities, and you will appreciate the difference between speed and velocity. The new quantity is here, speed or velocity. If we know the distance between the original position and the final position, which in this case we are giving the letter D and then S, or sometimes it is L, which is the length between the 2 points, then we can divide it by the time taken, which is T, and then obtain a value for the speed, so that we can say the object is moving fast, it's moving slow, it is moving, it depends on how you see it. If an old lady is moving and he sees young boys running here and there, the old lady, because she cannot run as fast, she will say the boys are running so fast. But if a snail were nearby, the snail will probably say that the old lady was also moving fast. That's fun, isn't it? Yeah. So we better put a value on how fast or how slow, and leave it to people to judge whether it is fast or slow. And we do that by measuring the distance and the time and finding the ratio between them. Now, let's take this particular instance. The particle moves from point O to A, and the distance covered will be, you can get it for yourself. is 18 centimeters. And the time taken is 28.20 seconds. So we know the how far and then the how long it takes. So we can move on to determine the speed. This is as simple as that. You can verify it yourself. I was doing that in a hurry. So just verify and let me know on the platform as well. We can do the same thing for the particle at point B. It traveled a longer distance of 28 centimeters or 0.28 meters, and the time it took was 50.10 seconds. You simply go ahead and then calculate the speed, which is 0.056 meters per second. You see, even though particle B traveled further, it was even slower than the particle A, which was exactly, a little bit greater than 0.06 meters per second compared to the particle B. It traveled longer distance, but it was quite slow, even though it traveled longer time. Until you calculate this, you find this ratio, you will not appreciate which one is faster. You may only perceive that B has traveled longer distance, but without the time, you will not be able to determine the speed. Okay. Now, in weights, the average speed of a body is the distance traveled per unit time. We are saying the average speed or the average velocity because if a particle is traveling, it may change its speed several times. Take a bus traveling from Akrokeri campus to Obuasi. Now the road is asphalted, but some time ago it was dusty. Many of you might have experienced that. You see, at some point it will be moving very fast, at another point very slow, at another it has to take so much care by moving very slowly and carefully. You see, so before the car moves from arrives at Obuasi, it might have changed the speed several times. Now we talk about the average speed of the vehicle moving from Akrokeri campus to Obuasi. It's like we are adding all the different speeds together and dividing by the total number of speeds that we are talking about. You know how to calculate average. But a much simpler way would be to measure the distance from Akrokeri to Obuasi Street and ask yourself, how much time did the vehicle take to travel from Akrokeri campus to Obuasi? Instead of measuring the different speeds it will take and adding them and dividing by the total number of speed that you've measured, you better measure the distance and divide by time, and that will be okay to find the average speed. That's why we call it the average speed. One way of calculating it is to find the total distance and divide by the time taken. Another way will be to take the initial velocity, add it to the final velocity and divide by 2. So there's a second way of calculating the average velocity. You will find the usefulness of these two approaches in our next lecture. There is another quantity that comes up as a result of the changes in the velocity that takes place when an object is moving. So that term for describing motion is called the acceleration. Remember, we are looking at the terms that we can use to describe motion. If a body is in motion, what are the words that we can use to describe the motion? The last one we are going to consider will be acceleration. What is acceleration? In words, acceleration of a body is the rate of change in velocity with time. And mathematically, we can say it is the final velocity minus the initial velocity divided by the time taken for the speed to change from the initial to the final. So we assume the object was moving initially, then all of a sudden it changed its speed from the initial to the final. So we have the initial speed and then the final speed. This time here refers to the time it took to change from the initial speed to the final speed, not the time for the whole journey. So take note of that. This is how we calculate acceleration. Even without calculating, you can determine that objects have accelerated from these few points that I'm going to that you can see on your screen. If an object at rest initially starts moving, then it has accelerated, because if it were at rest, the initial velocity would be 0 and it has started moving. So there is a final velocity which is not 0. So we can now take 0 from the final velocity and divide by the time it took to reach the final velocity, and that's acceleration. If it were already moving, then it can increase its speed or decrease its speed. In either case, the object has accelerated. Sometimes we differentiate between increasing speed and decreasing speed by using the term acceleration for the increasing and deceleration for decreasing velocity. So if an object changes speed, it has accelerated. Now, if it were moving and it comes to rest or it stops, it has decelerated, which is the same as acceleration. One important thing that many people may take for granted would be that if an object changes direction, it has accelerated. Keep this point clear. If an object moving in a straight line suddenly changes direction, it has accelerated. Keep this point in mind. Very, very important. It will be like a football. When somebody kicks football and the goalkeeper punches it or something, the ball changes direction and we say the ball has accelerated somehow. It need not increase in speed, it need not reduce in speed, but simply changing direction constitutes acceleration. Alright. So let's summarize what we've learned so far. We can describe motion of an object by its position, the distance, and the time taken. We can put the distance and the time taken together to form a new quantity called the average speed. And you know the definition, which is the distance per unit time. And this average speed itself may also be changing with time. If it changes with time, we say it has accelerated. That is the change in the velocity. Velocity is, for what we are doing, is the same as the speed. We get to appreciate the difference. But for now, we can talk about them as being the same. So velocity per unit time. So acceleration is the change in velocity or the speed per unit time. We'll talk much more about these quantities in other videos. Thank you for watching.